Hi, today I'm going to build the corner assembly. This is the third assembly in the JPL Open Source Rover build. In this assembly, I don't need to do any fabrication, but I did need to 3D print this encoder mount. The encoder mount can be 3D printed in many colors, but I chose light blue. Let's go check for all the parts. So, we have one 3-inch channel. We have one motor mount. We have one D shaft. We have one clamping coupler. We have one pinion gear. We have one encoder mount. We have one motor. We have one absolute encoder. We have 4 spacers. We have some threaded space standoffs. Got some screws. And that's all. Let's start assembly. It says motor mount. Begin by mounting the motor mount S9 to the motor E6 using screws procured with the mount. Once completed, insert the B5 screws that will be used to connect the mount through the 3-inch channel. Due to the orientation of the motor inside the 3-inch channel, adding these screws later is difficult. See figure 1. So, it wants us to take one of these motor mounts and place it on top of the motor. But what I recommend doing is taking one of these screws and putting it on here, because it makes it easier if you put this on first before you put it on here, because the motor is so close to the screw, it's hard to get it in. I completed attaching the motor mount to the motor. Now, it says 3-inch channel attachment. Attach the motor and the motor mount to the 3-inch channel using the threaded standoff T9 as shown in figure 2. So, it wants us to take one of these and place it on top, and take these threaded standoffs and put it on top. It says shaft coupler / standoffs attachment. Using the shaft coupler S38, attach the motor shaft to the 0.25-inch D shaft S15, figure 3. So it wants us to take one of these shaft couplers and put it on top here. And then take a D shaft and place it on top. And then take one of these wrenches and tighten it. It says 4. Encoder mount. The size and the tolerance of the holes will vary slightly based on the different 3D printers and materials. Press the 0.25-inch spacers T1 into the 3D printed encoder mount S31. If they do not fit easily, tapping them with a small hammer may help. If the holes are still too small, you can drill or file out the holes slightly until the spacers fit, as shown in figure 4. So, as I said, the encoder mount have holes that are too small for the spacers to fit. So, what I need to do is I need to file out the holes to make them bigger so that I can have the spacers to fit inside of the encoder mount. I finished filing. Now, I'm going to put the spacers inside. using a hammer. I finally got the spacers flushly inserted into the encoder mount. Now it says, next, attach a 0.25-inch pill bearing blocks S10 and the encoder mount S31 using the B5 screws and threaded standoffs T3 as seen in figure 5. So, I want us to take a pillow bearing block and place it on top here. And it wants us to take this encoder mount and place it on top. And then take another pillow bearing block and place it on top of the 3D printed encoder mount. Then take one of these screws and place it and I'm going to make sure that it lines up with all 3 holes. So now it wants us to take an encoder and put it through the hole in the encoder mount, and then take some washers and put it through here. And then I'm going to take a nut and then I'm going to secure it with a socket. Now, I'm going to put the pin-on gear and put it on top of the encoder mount, and I'm going to fasten it. So, all I need to do is make 4 more of these. They say that 2 of them should be exactly like this, and 2 of them should have the 3D encoder turned the other way. I got my second corner assembly done. So, I made the 2 corner assemblies with the encoders that are facing opposite directions. If I put this corner assembly here, and put this corner assembly here, and the body assembly goes in the middle. I got my 4th corner assembly done. So, there are 2 corner assemblies with an encoder mount facing to the left, and 2 corner assemblies with an encoder mount facing to the right. My next video is a differential pivot. Thanks for watching. Bye!